Hello and welcome. My name is James from the DSO Imager channel. Now, I've been doing astrophotography for about 5 years. I started in 2017, I guess really December 2016. And can you believe that I've never taken a picture of the Cocoon Nebula? Yeah, the Cocoon Nebula is a pretty common target for beginners in astrophotography. And for whatever reason, I never took a picture of it. I think part of it might have been because the star field is so rich, and most of the pictures I've seen of the Cocoon Nebula were just uh, the stars are just overpowering the image. And so I was just, at the time, I was just not that interested in maybe going after it. But over the past year or so, couple years, my processing skills, of course, have improved, and I started to feel like maybe I could tackle the star field. Certainly, with new tools available and techniques for de-emphasizing stars or removing stars, and the newer tools that we have available these days for noise reduction. I thought if I pointed my 115 millimeter refractor at it, um, that I might be able to get some detail out that you don't typically see in shots of this target. There's also a lot of HA, like background HA in this area, but it's completely obscured by the stars. So I thought I would go after this target starting with collecting HA and then see what I can get. And basically, I ended up, this turned out to be one of those targets where I just kind of parked my telescope night after night and not even paying attention to how much data I was getting. It was in a good spot, and so I was basically able to track the target, from sunset to sunrise. So let me show really quick the stats here on this image. So yeah, I mean I got a total of 63 hours on this. Now half of that was HA, and a lot of this HA was captured with a bright moon out there. But still, I mean, 30 hours of LRGB, so it's a lot of time. Now the funny thing is, and you'll see here at the end that the HA, I mean, it doesn't really look like 31 hours. Part of that, I'm sure, is my processing. There's certainly going to be more improvements there. But I wonder how much this is also playing a role. I'm starting to realize that if I want to do these wider field shots with and capture dark nebula and capture the ISM, right, interstellar medium, where all that faint ionized HA is glowing, I think I'm going to need a faster system. And so maybe I need to start considering something in the F2, F3 range. But anyway, let's take a look at what I got. So this is the luminance, and here's our red and green and blue. And all these images here, I've run dynamic background extraction against them. And there's our HA. So we can see that there's stuff here that you don't quite see in the luminance. And so this is what I was wanting to pull out. Now, putting the RGB together, this is without the luminance, and this is what we end up with. So, I mean, we get some nice color in there. There's still some color correction that needs to be done, but the method that I used for combining all of this is outlined on this website here. So I'll slide it over here. Now, it's a technique for adding HA to galaxies, and it works really well for that. But I've been using this technique for adding ISM to wide field shots as well, and it seems to be doing a really good job. You have to tweak with these values. Now, I posted a video uh, that goes into detail on the steps that I used. I'll put a link in the description. It's boosting your astrophotography with HA. And I show the process of how I do it. And I will include a link to this article in my description. This has become my standard process for adding HA to LRGB images. And so there's quite a bit of work involved in it. Basically, you have to have a red channel that's processed, DBE. You have to have an RGB image that's processed and ready to go. And the same with the luminance. And what you're doing is you're first isolating the HA data from the red channel. And I believe that is this formula here, yes. And there's a variable that you have to tweak. And what I ended up with was this here, this HA clean. So if you look at it, it's kind of ugly on the stars, but you can ignore this. The main thing is it's isolating all of this, right? So this is what I'm trying to add to the LRGB image. Now the challenge with this is that you can see how bright this is, and when adding this through the normal process, the HA in the Cocoon Nebula just overpowers it, and I get this really weird, weird pink. And so you can see that these are all different versions of tweaking these values, trying to find a combination that would work. And by increasing the value to get more of the HA in the background, it was just doing weird damage to the Cocoon Nebula. I mean, I tried to see if I could like make one of these work, and I did ultimately end up settling on this one where the Cocoon Nebula itself looked okay, but there wasn't that much. There wasn't as much of the HA in the background. It certainly didn't look like 30 hours of HA. And so I actually took a break from processing the image. I had to ponder how I was going to tackle this. Now I had tried putting a mask on here to like block this out when running the pixel math equation, but it just seemed like it ignored the mask. It didn't seem to have any impact. What I ended up doing is I did go with a mask, and now this is still linear, by the way. All these images are still linear. This whole process is done while it's linear. So I made a mask anyway, and I tried to dial back the lighting on this. So like literally I used histogram. I had to zoom in and just dialed it back a little bit. And that gave me this. So again, it doesn't look great in this state, but I felt like I'm getting enough of the red now, right? There's more red because this whole area down here should have red in there from the HA. So it looked like there was some potential, and this didn't look too blown out, so I thought maybe I could do something with this. Alrighty, so let's look at the processing. And you can see I have work here. I mean, I really spent a lot of time trying to make something work here. That's how it is sometimes. Alright, so this is what we ended up with, right? This was the 9th enhanced RGB combination, and this is with the luminance added to it. So this is HA LRGB, and this is what it looks like with the stars removed. So I definitely felt like there was some potential here. The HA is dark, but it's there, and so I felt like I can bring that out. Alright, so here we go, right? We're starting with curves. You notice a mask is on there, and What is that mask showing us? Yeah, so it's very subtle, right? But what's going on here is that there was some green uh, in this area that I'm trying to get rid of. So I literally made a green mask. So there wasn't a whole lot there, but it was enough, and then I could use SCNR, right? So it's subtle. I mean, look in this area. This is where the green was the strongest, right? So there's that green, and I use SCNR to pull the green out. Another cool thing, I mean, without the stars here, right? I mean, look at these galaxies hiding in here. That's one of the things I really like about removing stars, because yeah, the stars are really obscure. I never knew that there were some galaxies hiding in this frame. And this is with Star Exterminator, latest version. I think we're up to like AI 11 now on it. It is really good. It's I mean, you know, previous versions these galaxies wouldn't survive, but now these galaxies are here. And you used to get really blotchy spots where the stars are, and you can see that's not really the case anymore. In fact, we're seeing so much faint dust in here. I mean, yeah, I mean, it really makes me wonder what I would be able to get in my Bortle 5 skies if I was running at F3, if I had something like a Rasa or maybe a Takahashi Epsilon or something like that. But anyway, let's continue. So you can see I'm brightening it up. I have a mask over the Cocoon Nebula itself. This is an example of making two different masks and adding them together. So basically I made a mask that it's a red mask, right? Because I'm wanting to pull out that HA. But of course the cocoon is bright enough. I don't need to make that any brighter. And so I made another range mask that just kind of covered the cocoon. And then you use pixel math. I don't know if I have it. Let's see. No, it's not. But the formula is really simple. Here, let me just save that and clean it out. Basically, the formula is just simply you make your two masks, you invert one of the masks, and then it's just, you know, max and you know, the first one and the second one. I mean, that's like literally all it is. And you run that, you create a new image, of course, and you run that, and it takes the max values of both and puts them into a single image. And what you end up with is a mask that does this. So this mask is allowing me to brighten these reddish areas without blowing out the cocoon. So that's the whole goal there. And so that's what you're seeing. Now I noticed there was a color difference in the HA, and so I'm thinking that that's it's probably just a gradient, right? Especially since the HA was captured with varying phases of the moon, so I'm sure that had an impact. Yeah, I think that was the next step. Yep. And we got a mask on here again. So what I'm trying to do here is there was some color in these darker, again, color gradients. And so I'm just, when I do stuff like this, I'm either trying to brighten it so it doesn't get too dark, or I'm using curves and I'm pulling back on saturation to take some of the color cast out of it. And so yeah, we can see that I'm increasing contrast. Now I'm doing some work on here itself, on the cocoon itself. Try to get that color right. Doing a little invert, right? So you see, I mean, it's still kind of pinkish. I mean, personally, it doesn't look as good as the straight up RGB. I mean, if we go back here, where was that? Yeah. I mean, the color of the RGB is nice, and if I could figure out a way to preserve this, because I did lose some of this reflection dust in here. Maybe the answer is using Photoshop with layers or something. I don't know. So, I mean, the detail's nice, but I just wasn't digging this color. And so you can see I'm inverting it and I'm subtracting green. Not all of it, just a little bit of green. See the difference there? Because this right, the inverse of magenta and purple is green. So I inverted the image and I wanted to dial back the purple. And so I subtracted some green and invert back, and this actually is getting it closer to what the RGB image kind of looked like. The other neat thing is that we're getting all this like reflective HA. So I lost out on some of the blue, little faint blue patches, but I am getting some of this HA being reflected in the dust, which is still kind of cool looking. So anyway, we'll keep stepping through, brighten it up a little bit. There. Okay, so you see what I did here? I made another mask. So I made another color mask for red. And I wanted to get this purple out of here. So I just blocked off all of this. And I mean, what I'm doing, how I'm doing this is I'm just taking the mask into Photoshop and using the brush to, I'll either set the brush to white or black, right? And I'll just blank out this area so nothing in here is being impacted because we're wanting to isolate this. I'm kind of satisfied with this color for the most part, and of course I don't want to mess around with this anymore. So we just need to change this purplish to get it to closely match this, and then I just use curves too. I think I actually added a little bit of green and a little bit of red on curves, and then we're using a fresh red mask, but again protecting the Cocoon Nebula and trying to increase its brightness and make it stand out more. So I mean, again, this is pretty good, I think, but it's, for 30 hours of HA, I kind of expected to get more HA in this area. There's more here. I've seen a couple of pictures out there of some really fantastic astrophotographers running premium equipment in very dark skies. And I mean, this whole area is full of very intricate clouds of HA that I'm just not able to pull out here. So really, I'm just getting a hint of it as opposed to really resolving it. But stepping through, getting some more tweaks with curves. We're inverting again. Let's see, where's that mask? Yeah, so I think what I was trying to do here is that this dust had kind of a bluish tint. And really, the dust kind of should be browned. I mean, so I processed this, the first time I processed this, right, a lot less HA in here. And you can see kind of a brownish hue to the dust. But for whatever reason, I'm not getting that in this rendition of it. But I was getting like some blue and green in here. So we invert this again, make another mask, and I did another subtraction of green, I think. And that kind of took the color out a little bit. And yeah, here is, so I made another, this is just a straight up range mask. And what I'm doing here is, because I'm still not too satisfied with this color tint here, so I just removed I dialed back saturation. So, I mean, it gives us gray dust. It's not quite the pleasing brown dust, but at least it's consistent now on this whole structure. And let's see, more tweaks. I think that was about it. After this, it was a matter of adding the stars and doing some noise reduction, and this is what we ended up with. So there it is, my first attempt at imaging the Cocoon Nebula. It was a good target. I enjoyed it more than I thought I would. I think it was also a challenging target to process. I think it pushed my processing skills to the limit, and I think it also maybe showed the limits of my equipment. So if I want to do more of this kind of imaging, I might need to think about doing some equipment changes in the future. So anyway, if you enjoyed this video or you're interested in astrophotography, please give me a like and subscribe to my channel. If I'd love to hear what your comments are on this, what you guys thought about the final image, any suggestions, any processing tips, or different ways to manage this. I'd love to hear them. And other than that, clear skies.